true. All right, I think it's time, right? So,
Sure.
Yeah, let's start. So, welcome everybody. This is another webinar sponsored by the Language Technology and Data Analysis Laboratory. This is part of the webinar series 2021 and the opening event of LADAL. Before we continue, I'd like to read out an acknowledgement of country, because the LADAL, the Language Technology and Data Analysis Laboratory, has been established and is sponsored and supported by the University of Queensland School of Language and Cultures. So I want to acknowledge that basically the land on which the university does its practice is owned, and the custodians of the land are not people who work there necessarily at the moment. So the University of Queensland acknowledges the traditional owners and their custodianship of the lands on which we meet. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognise their valuable contributions to Australian and global society. If you want to know more about LADAL, there's the link to the homepage. You'll find tutorials, introductions, news. You'll find information about the people and a lot more tutorials on different aspects of working with language data. You'll also find information about the opening webinar series, such as abstracts and information about the speakers. Feel free to check it out. You can follow us on Twitter by using the handle @slcladal. And you can contact us directly using the email address slcladal@uq.edu.au. It's a pleasure for me to introduce today's speaker, Vos. Vos is a doctoral research fellow at the Arctic University of Norway in Tromsø. Was supposed to be studying incremental processing of aspect and modality in English, but got sidetracked by figuring out how to do that using webcam-based eye tracking, which is a real blessing for us, because that led to Myrte being very proficient in setting up online experiments and acquiring data online using open source software, which is the topic of today's talk. So in today's talk, Myrte will show us how to gather data and create online experiments using jsPsych and JATOS. So I'm welcoming Myrte, and I'll hand over to you. Thanks so much for agreeing to be part of this webinar series.
Thanks, Martin. I'm really excited to be here today. It's early morning for me, late afternoon for those of you in Australia. Hi, thanks for being here either early if you're in Europe, or at the end of the day if you're in Australia. Either way, I'm really glad you're here. Today, I want to do a speed run through building an experiment entirely from scratch. This will be consequentially a kind of a slightly chaotic way of giving a talk as such. So I'll be sharing my desktop most of the time, and I'll be clicking through different windows, and I might make a mistake here and there. That's all very, an authentic part of the experience of building an online experiment. But what I want to do is just show you the entire process from an empty code editor and no files and no idea where to start, to having the thing written, uploading it to the server where you want to host it, and distributing links. And I plan to do all that within less than 1.5 hours, but I rely on Martin to give me a heads up if I'm in danger of running long. So,
I'll let you know.
Thanks. So before I start sharing my screen, I just want to talk a little bit about the tools I'm going to use today. Don't worry if I'm going too fast. That's kind of by design, because the recording will be made available later. And there are loads of slower videos and also text-based tutorials out there if you want to try this yourself. So jsPsych and JATOS both have excellent documentation on their homepages. Kenny Smith from the University of Edinburgh has in the past year put out a lot of excellent materials for JSPsych specifically. So there's a lot out there. If you're really interested in trying this yourself, this will be a taster, but actually the teaching and learning, there's slower resources out there. I just want to give you a taste of what's possible, what the structure of your script looks like, and all of the steps that you need to take. So what is JATOS and what is JSPsych? So let's start with JATOS. And for this purpose, actually, I just want to very briefly share my screen. See if I can. Yeah. So JATOS is, it stands for just another tool for online studies. And it just does what it says on the tin. It's a server, or it's a software tool with which you can configure your own server. So you can host and run experiments online. You may have heard of Gorilla, which is a commercial service that does the same thing. So JATOS and Gorilla both give you a place on the internet where you can host your experiments and where you can collect, store, and manage data from those experiments. So in Gorilla's case, the server is owned by a company in the UK, but if you're using JATOS, then what you'll ideally do is you'll ask your own IT department or IT services at your institutions to install JATOS on its own server. So that's owned by the university or by the institution that you work for. And JATOS is free and open source, and it's created and under active development by Lange and Filevich. So the great advantage of using something like JATOS as opposed to a commercial third-party platform like Gorilla, or there's other examples, FindingFive, if you're in the US, for example, is that you're in full control of your own data. There is no third party, there's no middleman. Participants access your private secure server directly. The experiment is hosted there and the data is collected there and stays there. There's no transfer through any other servers anywhere else. And this is nice. The privacy and ethics committees are a fan of that, especially when the data you collect is sensitive, like video or audio recordings or medical information. In Norway, our ethics department is very strict about these things. So this is really why we ended up using JATOS, is because there were very few other options available to us if we wanted to do the kind of online research that we wanted to do. So last year, our IT department agreed to create a JATOS server for us. And by now, we have about 25 users. We have over 90 studies, and we have close to 19,000 results. So we've been very happy with it, and it's been very productive for us. So another difference between JATOS and Gorilla is that Gorilla also lets you build experiments. It has a nice graphical user interface. JATOS does not have that. What it does, it offers you an environment and it offers bits of code that you can insert into your experiment code to give it cool functionalities when you run it on JATOS. But you can't build a whole experiment using JATOS. It's not like, I don't know, some of you might be familiar with Open Sesame or PsychoPy, these sort of experiment builder programs where you can almost like drag and drop and put together an experiment that way. That's not what JATOS is. It gives you the place where you collect the data. I'll just log into my own local JATOS to demonstrate. Just to give you an idea of what it looks like. This is my local one. We'll actually use the university one, the official one. So this is what I've used, for example, to run my webcam eye tracking experiments in the past half year. So you get an environment like this. I have all my studies in the left sidebar here. I have a couple of menu options up top. This is the home page for one of my eye tracking experiments. It has an info and consent page that looks like this. and that will redirect me to the experiment proper if I click on I agree and start. I won't do that now. As you can see, it's got about 200 results that I can search through, sort, filter, using all kinds of associated metadata that's also collected via JATOS. And I can also look into, I can preview. So that's just to give you a sense of what the environment looks like. I think it's pretty intuitive and it's pretty user-friendly. So later in this tutorial, you'll get a bit more of a sense of what it feels like when you start building an experiment for this platform. This is really handy to have if you've already built your experiment and you upload it to JATOS and you run it there. But how do you build the experiment? What do you use to actually build the thing? Anything that you've written in the languages of web design, that's HTML, CSS, and JavaScript, you can run on JATOS. That gives you a lot of freedom, but most researchers aren't such skilled programmers that they can build sophisticated experiments from scratch. Like I myself was in that position a year ago. So do you have to become a web developer to run experiments on JATOS? I don't think you do. So what I like to use is a JavaScript library called jsPsych, which is a library for running behavioral experiments in a web browser. JSPsych is designed a little bit like Legos, is the metaphor I like to use. It's got the Lego pieces are called plugins, can be combined and put together in this timeline. I'll show you later how that works, to build your experiment. And if you've absolutely never programmed before, and I guess it's a bit of a steep learning curve, but if you're familiar with R, it's already a little less scary. There's a lot of good, clear documentation for which each of the Lego pieces do, each of the plugins. So you've got a whole list of them here, and the plugins sort of come with the JSPsych software package that you download to your own computer. So a lot of these are very simple things that you might want your experiment to do, like present some text or an image and get a button response. So the nice thing of having a plugin like this is that all of the code that supports this functionality is already written. It's a template. So really all you have to do is call the plugin in your experiment script and tweak some parameters. So for a lot of the things, at least the basic things that you want your experiment to do, there is already a plugin, as you can see. When you get a little bit more proficient with Java programming, then you can start building your own custom plugins. And I have an example of that towards the end if we have time. So JSPsych, like JATOS, is free and it's open source. It's under development by Josh de Leeuw, who is assistant professor of cognitive science at Vassar College. It's also currently being supported by Becky Gilbert of the University of Oxford and loads of full volunteer contributors, because that's the nice thing about open source. So that's about as much as I'm going to explain about the software tools up front. If there's any questions about that now, I encourage you to ask them. If they're short, I can address them now. Otherwise, I'm going to launch into the speedrun part of this talk. No questions? Awesome. All right. Give me a second. Lost my Zoom menu controls. Voila. All right. Okay. So what you should be seeing right now, if I'm screen sharing correctly, is an empty document in a code editor. I use Visual Studio Code, but there's other good free alternatives available like Atom, for example. What I'm going to do is I want to build a simple image categorization experiment. I want to show participants pictures of animals and have them decide whether the picture is of my cat or not. And I might also want to add some other stuff that you might want to have an experiment, like some demographic questions and maybe some performance feedback at the end. And if we have time, I might add also a feature I've developed last week, the possibility of recording the voice of your participant for certain functions. So what I want to do as the very first step in building this experiment for JATOS is to create an experiment on JATOS. And I'm not going to do this on the real JATOS, the one that's connected to the internet, because I don't have access to the assets, to the study files from there. And you also really don't want that. You don't want to be able to tamper with your experiment code when it's live on the internet. So what I'm going to do instead is go to my local JATOS, which is practically the same. It's just downloaded on my own computer. And I know exactly where the files are. So first thing I want to do is create a new study. And I'm going to call it Magnus, which is the name of my cat. Actually, I'm going to capitalize it because that's polite. So just going to and I'm going to give the folder where all of my study materials are going to go a name. Just going to call it Magnus. All of the other fields I don't really need to do anything about right now. They have their function, but not at this juncture. So create. And there it is. It's got nothing in it yet. I'd like to add a study. Something that I can run. Let's call it my cat study and allow reload. This is very important. Do you allow your participants to refresh the page and reload your experiment? Often you're going to want to leave this unchecked, but for the purposes of development, this is useful. All right, and this is very important. We need to set the HTML file path, but we don't have one because we haven't created any files yet associated with the study. So we're just going to leave this empty for now. So we have the component ready to go. It's just not linked up to any file yet. Okay, so we don't have a file. Now what? What I've just done is I've created a file for my study materials in my JATOS folder on my own computer. It's in this folder, study assets. So you'll see that all of the files in here are associated with a study on my local JATOS server. And there should now be, and there it is, a folder named Magnus that I've just created. And there's nothing in it. That's expected. So the first thing I want to do before I do anything else is copy over the JSPsych directory into my Magnus folder. So I have access to all of the software that I need to build a JSPsych experiment. And I am just going to copy all of this and copy it over. And I'm just going to talk briefly about what's in all of these folders. So this is the main script that you use to run JSPsych. You never have to go into it or tamper with it or do anything about it. In fact, I encourage you not to. Better to not mess with that. This folder here, CSS, only has one file in it momentarily. CSS stands for cascading style sheets. This is where all of the sort of visual formatting and animations and behavior of your web code ends up. This is a fairly bare bones file. It's just to make, to give all of your JSPsych code a little bit more of a unified style. Again, we don't need to worry about that. This is really the important folder. This is where all of our Lego pieces are. So I've shown you the documentation for each plugin on the JSPsych website, where you can get a description of what each plugin does and an explanation of all of the parameters that you can customize and an explanation of the data that it generates. Often there's also some examples towards the bottom. So I have this page, this jspsych.org page open in my browser somewhere permanently because I need to use it so much. But the actual scripts are in this folder, and that's where you want to draw on them. And again, we don't really need to do anything about that now. So there's one very important file missing from this folder at the moment, and that's the HTML file that needs to link to the study component that we've just created here. So we're going to create that now. And for that, we're going to my code editor. So I've already created a new untitled file here. I'm going to select language. No. And I'm just, before I do anything else, I'm just going to save it. I'm going to save it in this new Lange file that I've created. And rather predictably, I'm just going to call it lange.html. Often this file in more professional experiments or really anything programmed for the web will just be called index.html, sort of to indicate that that's the starting point for everything else. But I'm calling it lange.html. I've had the entire experiment already written out in a different file towards the right here, and I'll just be copy pasting into it just to save us all some grief. So here we go. We have our file. I'll just set the file path before I do anything else. It won't be useful to us because there's nothing in it yet. But that way I won't forget. There. Now the file path is set. But there's nothing in it. So what's the first thing you want to do is you want to create the head. The head in an HTML file is where you sort of specify the paths to all of the various code ingredients that you're going to need in your script. So you'll recognize a lot of the things I've already pointed out to you just now. The jsPsych.js file, just actually grab the folder so you can see. I need to call this. I need to reference the JATOS.js file. It's not in here, but it doesn't need to be. It's on the server where we're going to run it. So you don't need to worry about that. There's a few plugins that I'm planning to use. I specify those here. There's style sheet, of course, very important. And if we get to it, there's a couple of extra files that I plan to use that I've just bundled below. But that's what you need to specify in the head.
Mirte, I have
Yes.
a quick question.
Of course.
So where does this come from? I mean, if I were completely new, right, to JSPsych, where would I find that? Is there a resource that I could use that would give me, for example, the file that you've used on the right to copy that into my script window?
I feel like there's several questions in here that I can give different answers to.
Right.
Are you asking where you can download JSPsych, the software package?
No, I'm asking, how do I know what to put in the header? And is there a template I can use?
There are templates. There's loads of templates. In fact, if we go into Magnus, you'll see that there's a folder titled examples. Mm-hmm. That contains loads of different HTMLs with example code for a lot of the different plugins that I've hinted at. Does that help a little bit? If I just open one of them. Here's one.
Yeah,
for example.
like if you look to your right, okay?
Yeah.
What file is that? The tutorial minus HTML, right?
I see. This is a file that I've created for myself. What I will do is when I'm done here, I will make all of the materials for this talk available on my GitHub page.
All right, thanks so much. Because
that's what you were
wasn't clear where that came from, right?
No, where it came from is I made it. I wrote it myself. And I'll just be copying over from right to left because I want to show you how it's built up. But you really don't want me to write this from scratch in real time.
Yeah, no.
That's going to be a frustrating exercise for all of us.
Yeah, I just want to clarify that that is not something that basically is there once you open the editor, right?
No, absolutely not. No, this is a file I've created earlier, and that's already written for the purposes of this talk. And this is me recreating the process of writing that in a fresh file.
Yeah, awesome.
That's what's going on. Yeah, thanks for making me clarify that. All right, I won't dwell on this long because it's a little bit more niche or advanced than we really need today, but under the head, sometimes you can add style tags. Once you have too many of these, you really want to create your own style sheet for them. Again, that then becomes a CSS file, and you want to put that in the CSS folder. But for today, I really only want to set 2 style rules that apply to the entire experiment. I create style classes. I want to make sure that the images I present today are 500 pixels wide, unless I specify otherwise. And sometimes I want to be able to left align my text instead of JSPsych standard center align. So those are just 2 style rules that I want to be able to draw on if I want, that I specify up top here. Then the body tags, we're not using those because we're going to fill, you know what? No, that's too technical. I'm not going to go into that. Suffice it to say, we're not going to use the body tags. What we're going to do is use the script tags. This is where all the fun stuff happens, where your code goes. So the first thing I do usually is just add some common code to tell myself what this is. This is just a good practice to do it anyway when you start programming these things, is just add as much common code as you can stand. Even if you're just programming for yourself, future you will not remember what this is, why you did it, why you tried to build this particular thing. So just common code all over the place. It's also very useful when you're testing things, is to be able to activate or deactivate code. The very first thing now that we want to do for our script is to create the timeline. Variable timeline equals an empty array. The timeline in JSPsych is, if you can visualize it at best, I think, as a literal timeline, a line along which you add things that happen, events in your experiment one by one. And you can loop over some of those events maybe, or jump ahead or back. You're going to define each of those events in your experiments as a new variable, the way I've done with my timeline. But then as you define those events, you're going to put them in the timeline. And then when you've done all of that, you're going to initialize your experiment and run that timeline. And I'm just going to insert the code for that right underneath, actually. So our experiment still has nothing in it yet. It has this empty timeline that I've just created. It has the call to load JATOS, initialize JSPsych, and run the timeline. which so far has nothing in it. I don't want to show a progress bar, and when the experiment has finished, I want to display the data on a screen. That's all this code really means at the moment. So let's start adding things to it. And I'll just add the HTML closing tag as well at the bottom. So what do we want to add first? Well, we're going to use pictures in this experiment, pictures of my cat and of other pets. So where are those pictures actually? Let's just. We're going to need a folder, of course, containing the media, the images and the stimuli that we're going to use. So that's this folder that I've created, img, and I'm just going to copy it over. So now we have a place where we can find our images. And in the script, we need to specify the file paths that we're going to need. You also want to preload those images before you start so that you don't get lags in your experiment when the pictures are being downloaded to people's computers in their browser when they're running your experiment. Just a little thing that often you don't really need to think about when you're running this kind of thing in the lab, but when you're doing online experiments, this stuff starts to matter a lot. So we want to preload our media. I'm just going to add the first plugin that we see in our experiment, the preload plugin. There is a plugin to preload media, and what we're going to do is manually specify an array of file paths that this plugin should preload for us. In running the actual experiment, we're not really going to see this plugin at work, not unless it takes a long time, which it won't, because it's just 14 pictures. Once we've called the preload plugin, set the list of file paths that we want to preload, and instructed the plugin to show us detailed errors if something should go wrong, then we can push this variable, this event on our timeline to the timeline. It's going to be the first thing that goes in there. But we don't have a list of our file paths yet, so we're going to make one now. In bigger experiments that I build for myself and other people, this gets a bit more complicated. I tend to parse the data or the stimuli and the annotated stimuli that I want for an experiment into the code from a CSV file. I'm not going to do that today, just for the sake of simplicity, but also for the sake of demonstration, because basically it's the same thing. What I want to do is create an array. And I've pre-written it here. An array containing, most importantly, the file paths to the images I want to use today. You see those here. So within the curly brackets on each line, you get 3 different pieces of information. These are called key value pairs. So this key is called picture, and the value for it is the file path to the picture I want to use for each trial. I also am going to want to use keystrokes as responses to these pictures, and I've set the correct key response to each of the pictures here. And finally, for reasons that will become clear later, I also want to annotate these stimuli with a name. So each trial gets its own curly bracketed line, and these 3 key value pairs are in there. And really, when you have your CSV file with experiment information, which most researchers I've met have a file like that when they start building an experiment of any kind, really that's all this is. This may seem familiar to you, as you have the key value pairs just become column names and information. So we've written that out here. and this will be useful to us later. We've stored it inside an array. And as you see in the preload plugin down here, the preload event, I've said that the list of file paths that I want to supply to this plugin is called all pictures, but there doesn't exist a list called all pictures yet. We're going to make that now in a neat little for loop. So what have I done here? It's very simple. I've created this list. It's an empty array again. And this for loop, all it says is really, so for each of the lines inside the experiment variables array, for the length of that array, count one more. So this line is essentially a way of sequentially going down a list, this list. So for each of the items inside this array, grab just the picture key value pair, this bit, not this bit, only this, and push that inside of the new array. And that's what we're going to give to the preload plugin. And that's what that plugin is going to use to preload all of the pictures associated with these file paths. Underneath, I've added the command console log all pictures just to check whether that's actually been successful. I use this a lot when I'm doing this kind of experiment development because it's a good way to check whether the code is outputting what I mean it to output. If I save this now, we should actually be able to see this in action. We're not going to actually see anything useful on a screen, but we are going to be able to see whether this bit of code works. And to do that, I'm going to show you this useful tool that I use a lot. If you right-click on any given web page, you'll get the option Inspect. Which will allow you to look under the hood of whatever web page you're working with. This is going to be useful. The console is down here. Just going to make it a little bit better. And this throws messages about what's happening on your web page. So what we've just told it to do is to give us a console message for this list of file paths that we've just created. And we'll see if that works. So in the console window here, usually a red message is very worrying. In this case, I know what's causing that, so we don't need to worry about it yet. But the important thing is that this list we've created, all underscore pictures, successfully was created, and so has successfully loaded. You can see that in the data output. So our experiment is already working. It's not doing anything we can recognize as an experiment, but the code we've written so far, I can already tell is working. Neat. So that's our first, the first thing we want to do is we want to make the stimuli and the annotated information associated with the stimuli available to us within our experiment, and we want to preload the media. Now it's time to actually write stuff that we can see. So that's usually a welcome page of some kind. In my case, I've also decided to combine it with a small survey where I want to collect some demographic information about the person who's taking my experiment. So I'm just going to copy all of this over, and we'll have a look at that. So what's going on here? I've created an event, a variable called welcome survey, open curly bracket. It's of type survey multi-choice. It's a survey with radio buttons where people have the option of selecting multiple options. It has a preamble up top where I've specified the text to be welcome to my experiment. The text is also going to be blue. Okay. This code, this dark orange code, is HTML code. Hypertext markup language. So in this event, I get to specify 2 questions, or as many as I want, really. In this case, I've done 2. You'll recognize the same format that we've used up here for our experiment variables array. Same format applies here. You create an array, and each line, bracketed by curly brackets, is a distinct object. And within it, again, are these blue key value pairs. So this structure returns a lot, and eventually it becomes quite an intuitive way to think about the way that information is organized within your script. So there's 2 questions. For the first one, the prompt is where in Tromsø do you live? Assuming that your participant is where I am in Tromsø. You want to give this particular question a name that'll be useful in your data output. And you want to give your participant options. I'll get to that in a minute. And you want the question to be required so that they can't move on in your experiment before they've actually responded to it. The second one is a question about age. What I've added is a neat little feature where after this event has finished, the participant has responded and it has clicked the button next to go on to whatever's next. I've instructed JSPsych to do some creative math on the data. What if in my data output, I want to classify the responses as a certain way? So if I can create a new key value pair in the data after my participants have responded, and say I want my data output to already tell me whether my participant, when they've responded to the question, where in Tromsø do you live? I want my data output to reflect whether they live on the island, because the city of Tromsø is built on an island, or whether they live on the mainland or on a neighboring island. So I've used a little if-else loop for that. All this code really means if the place, so if the response to the place question is Centrum, Hamna, or Stalheim, then this new key value pair I've created will have the value Tromsø in the data output. If this is not the case, else, we're just going to classify it as other. That's nice. That'll be useful, maybe. You can use this for all kinds of stuff. You can conceive of writing all manner of functions that you might want to perform on your data after the event is finished. But you'll notice that we don't really have response options yet. Instead of specifying them with HTML, I've just added variables, but I haven't defined those variables yet. I've done that just to keep the code neat and readable. But I do need to specify those options. So I've just created, again, arrays for those response options. One called place, containing all of the possible response options for where in Tromsø do you live, and one for age bins, for the question, how old are you? All the way at the bottom of this code chunk, I've again added the important command timeline push welcome survey. So this should be functional code, and we're just going to check that. I'm going to remove the inspector for a moment. I'm going to refresh our experiment. Hey, presto. There we go. Where in Tromsø do you live? Well, personally, I live in Centrum. Don't Google that. And I am barely between 18 and 30 years old. So this is one of those neat little things that jsPsych style has set for us. Is if it's a required question, it adds this little red star so that you know that you have to respond before you can continue. So stuff like this, the specific way that this continue button looks, or the way that it turns gray when I hover over it, or the fact that that star is there, that's all stuff that I don't need to code. That's already in the jsPsych software. If I click on continue, we're just going to go to the end of the experiment, to the data readout that I've asked for. And you'll see the data output for our preload plugin, where we've still successfully preloaded our media. And we'll get a preview of the data output for this welcome survey that we've just created, where you'll see that we get a reaction time. That might be useful. And we get an object with our responses. You also get the order that the questions were asked in. Sometimes you get to randomize the question order if you want. And in the rest of the data output, you'll see this key value pair we've just decided to create from scratch in the onFinish function, where the code that I've just shown to you has successfully classified my response to the question about place as I live on the island Tromsø. So this is neat. You're not necessarily going to want to show your participants this, so you can turn that feature off when you're done developing, but at least while I'm writing an experiment, I really like to be able to see the data readout of the things I write, so that I can check whether this is actually the data that I hope to get from my experiment. Hey, Martin, how am I doing on time?
You're doing fine.
Awesome.
Yeah. Let's
add some instructions. There's a plugin for that. That's very neat because it lets us have an instructions event with multiple pages. Again, hopefully you're starting to get the hang of how this works. We're creating an event in our experiment called instructions. It's very, very helpful to name your things intuitive. We'll give it intuitive names, just as preschool as possible. I cannot stress enough how future you is not going to understand what your intentions were if they come back even 3 days later. We're going to call it instructions. It's of type instructions. Plugins have a name, and you call them like this. I'm going to specify the labels that I want the previous and next buttons to have. Obviously, in this case, it's pretty obvious, but if I'm doing this in a different language, that's something I want to be able to customize. And I'm going to specify the pages for my instructions trial here. I'm not going to dwell exactly on how the HTML works. There's a lot of documentation for that. And I know it looks a little bit like word soup at first glance, but you get used to it. I prefer to just show you what it looks like in the experiment in a second. I've added an optional style class if I want to align the text in this trial to the left. As you remember, I created a rule for that up here. That's an optional parameter I can call. I've decided actually I don't want to do that. So I'm just going to toggle it off. This green code is code that just is not going to get read. It's going to get skipped over. So that's nice. Sometimes I like to write something in as something I might want to use, but I just toggle it on or off like this. Also a good way of checking what is making your code break. I want clickable navigation, but I don't want to see page numbers. I don't think we need that for only 2 pages of instructions. At this point, I just want to remind you that every plugin that comes with the jsPsych software package has its own documentation page. And all of these parameters that I'm showing you, right, all of these different options that you can customize, are listed for each plugin. So there's no way that you can remember, even when you use them a lot, what they all are. So fortunately, there's just a list of them on every single plugin page on the documentation. So you'll see a few, and you often don't need to specify every single one of them, right? So instruction has kind of a lot of them, but they often have default values. So if you just don't reference them, they'll default to whatever the default value is here. So I only need to specify a couple. And again, we push it to the timeline. And I'm just going to check if it works the way I intended. Hey, instructions. My instructions are that in each trial, you will see a picture of an animal, and your job is to decide whether it's a picture of Magnus, my cat. This is Magnus. At this point, feel free to coo and applaud as appropriate. If you see a picture of him, press M on your keyboard. If it isn't him, press F. If I click on next page, there's not going to be a next page. We've reached the end. So these are my instructions. At this juncture, we might actually want to have a practice trial. And this is where we're going to use the actual plugin that we want for our experimental trials for the first time. We're going to call it practice. Again, nice transparent variable names. And it's of type categorize image. This is a plugin that's designed specifically for the task I'm trying to do today, which is just show pictures and have your participants categorize them using a keyword stroke. So as you can see, there's a few more parameters that we want to customize here. I want the key to be associated with the correct answer to be M. The stimulus is just going to be the picture that I've showed you just now, a picture of my cat. And I'm going to hard code the image file path for now. The two choices, as the instructions already told you, are M and F. There's something a little bit nifty going on here in the following couple of parameters where I specify that the correct answer in text is Magnus, the name of my cat, and then I can call that as an answer variable in other parameters, namely if I can set feedback for this particular type of trial. If I use the correct key, then I can get a line of feedback text reading, correct, that is Magnus, or can't you tell that's Magnus? Try again. So this is really neat. This is very useful now. I'm just going to foreshadow that we're going to run into problems once we want to run a whole bunch of these trials with different pictures and different types of animals. But we have a solution for that, and I'll get to that in a minute. I've set the trial duration as null. That doesn't mean that it's going to take no time at all. It means that there is no set time that it can take. Sometimes you might want to have a forced duration for a trial. In this case, I don't want that. I just want to show it for as long as it takes to have a response. I want to keep showing the picture of Magnus when the feedback is delivered. True. I want to force a correct button press before my participant is allowed to continue. True. And I want the feedback to be visible for 3,000 milliseconds or 3 seconds. Those are the things I want to specify. And I'm going to push this to the timeline. So let's try that out. Just going to click through my survey again. And click through my instructions again. And here we have our practice trial. So for demonstration purposes, I am going to pretend I don't recognize my own cat and click on F. Here we have our feedback. And this trial is not going to move anywhere until I give it a correct button press. So I'm just going to press M now. We move on, and there's nothing else in our timeline, so we go to the data readout at the end of the page. Awesome. That seems to be working well. So now we can actually create the trials themselves, and this is going to get a little bit more complicated. But I'll walk you through it. So what I've hinted at earlier is this practice trial is only one trial. It has one hard-coded stimulus file path, and it has one correct answer. What we want to do now, though, is we want to present like 14 of these, and it's a complete pain in the behind to write this out for every single trial that you want to run, right? You could do that. It's an option you have, but we want to avoid writing more code than we absolutely have to. What we want to write really is a list of trials that we loop over. And this is something that we should be able to do quite easily because we've already created this list up here, right? We have our array of experiment variables. Really what we want is a little loop that just goes through this list one by one, by one, by one towards the end. This is something that computer code is designed to do. This is something we want to take advantage of. We want to create trials of exactly the type that we used in practice. Really, we're changing almost nothing, but we are going to use variables to supply the parameters. And we're going to draw those variables from the array of annotated stimuli I've created up here. I specify those variables here. So let's start from the top here. I'm going to create a variable called trials, note the plural. So far, all of the events I've created have been one-offs. But this is its own little nested timeline. You can do that. You can nest timelines within timelines as many times as you want. So I'm going to create a timeline within a timeline. And this timeline is really only the same trial being looped over this array of variables again and again until it reaches the end. It's also going to do that randomly. I specify that here. I've also included some code that I want to use. Is that it's not going to do that over the whole array. It's only going to sample 4 of those items. That's just to save time for now. For the full experiment, obviously, I want to turn this off. But for now, let's just sample 4 of them. And within this looping timeline that we've created, we need to define only one trial because it's the same thing we want to do every time. We just want to vary the picture we're seeing, the correct response we want to give, and the feedback text by each individual trial. And we use that, we do that using jsPsych.timeline variable, where we call the keys in these key value pairs. This is much neater than writing out the full file path or the full text every time. This can be a bit much to wrap your head around when it's the first time you encounter it. So if at this point anyone wants to ask for clarification, please do so. Awesome. I'm going to take that as encouragement that I've actually managed to explain this with any measure of success.
Yeah, I think so far it's been pretty straightforward.
Yeah, so you'll see that it looks pretty much the same as in our practice trial. Just the variables that we want to change with each trial are now a variable. So let's see if we can see that in action. I've pushed my little nested timeline to the main timeline. I'm going to save the file, very important. I'm actually going to turn off my welcome survey and my instructions for now. So I can move straight on to the practice trial. And that's what happens. So I'm going to correctly classify this as Magnus. And now we start with our trials proper. So this is a cat we haven't seen before. And it's not Magnus as far as I can tell. So that's correct. It's Niels' foster cat. But this, is this Magnus? No. That's Nora's housemate's lizard. This might be Magnus. Hard to say. But it's not. It's Paula's cat. How about this? Is this Magnus? No, that's not Magnus. So you'll see I've set a limited amount of time to show feedback. The feedback duration for the trials proper is now only 1.5 seconds. If we want to make it longer, we can, but I won't for now. So that works as intended, as far as I can tell. So this is really the main meat and potatoes of the experiment that we wanted to build, right? Let's see. I've gone about an hour, so I have some time to add some extra cute bells and whistles before uploading it to JATOS. That's nice. At this point, if this is all you wanted to do, and you wanted to show the full array of options, then you want to turn this off again. So the next time we run this, you'll see all of these in random order. If this is all you want, then you might want to have a quick sort of thanks for participating page here. So we'd probably use an HTML button response plugin for that. Just show some text, have a button that reads something like finish or exit experiment, and then, you know, voila, that ends your experiment. But before we do that, I'm going to add an event that gives feedback about your participants' performance, because it's nice to be able to give your participants feedback about how they did. And this will demonstrate how you can, as a stimulus in a plugin like this can be just a bit of text, or it can be a picture, but it can also be a JavaScript function. So this looks a bit scary if you don't really write functions a lot. I've just gotten this from an example on the jsPsych website, so that's cheating. But once you get a little bit proficient in something like JavaScript, and people who use R regularly will also recognize this, at some point you just want to write functions for stuff because it makes your code more powerful, and it makes your workflow more efficient. So what we've done is we've created a feedback event. It's of type HTML keyboard response, meaning just you show some markup language, and then your participant responds with a keyboard stroke. Any keyboard stroke, unless you specify a particular one. The stimulus, though, instead of being a picture or some text or whatever, is a function. Within this function executes when the feedback event begins. You define a variable called trials. You fill that with data that you've collected in your jsPsych experiment up to that point. You filter for data that is annotated with the key value pair task trial. It's kind of sneaky of me. I've already done that up here in the trials event. That may have seemed like kind of superfluous information at the time, but for the sake of this feedback event, that's information that I want to tag my trial data with so that I can filter for it later. Now, I'm going to define a variable correct trials. I'm going to filter this variable I've just created again for trials that were correct. Because again, that's data that's collected as a data output of these trials.
Mirte?
Yes?
Just real quick, I just want to update you on the time. It's 10 past
Sure.
10 here in Germany at the moment.
Yes.
So we're 1 hour and 5 minutes into the talk, just
Yeah.
to give you the information.
I'm aware. I think I'm gonna stop adding things to my timeline after this, actually, unless there's a real desire to see the audio recording plugin, but maybe we can actually save that for the question answer if you prefer. What do you think, Martin? Just to give myself enough time to upload to JATOS.
Yeah, I think the audio plugin would be a good idea to include in the main talk.
Awesome, let's do that.
Yeah. All right.
Then I'm just going to very briefly, you're going to have to take it on faith that the rest of the code that we're executing within this function is going to calculate the percentage of correct trials with a correct response. And it's going to return as an output of this function a bit of text that says you could responded correctly on accuracy variable % of the trials. And your average response time was reaction time milliseconds. So this is, under certain circumstances and in certain experiments, maybe a fun thing that you want to be able to give your participants, or maybe you have an experiment where you're training them to do a particular task, and then it can be good to get some feedback. So I'm actually just going to demonstrate that real quick with the, oh, for Pete's sake. With the sample I've created. Ooh, I'm seeing a lot of red squiggly lines. There's an error in my code. What is it? Ah, I see. Voila. Accidentally deleted a curly bracket. This is the least fun part of coding, is where you create an error in your script and it's just a spelling mistake. So let's just really quickly demo this. This is our practice trial. We're going to have a random sample of 4 of our trials. Just going to make a deliberate mistake. Let's say this is Magnus. No, it's not. It's Tiger. And this is our feedback event. I did indeed respond correctly on only 3 out of 4 trials. So if I press any key now, that ends my experiment. So this would be enough to have a full and complete experiment, right? This is all we need. But I've prepared a little bit of extra using a set of a new plugin and some associated materials that I've developed last week, which we can use to record a participant saying something in response to something that we give them, which I think is a pretty exciting thing to be able to do, especially if you're a linguist. But we're going to need some reinforcements for that, because the materials that I need for that aren't in my Magnus folder at the moment. I just need to copy those over real quick. This folder called elicitation. I'm going to paste those over. If you recall, back when I was defining the head, I kind of glossed over this bit. These 4 lines listed under audio elicitation. These are 4 files that I need to make my audio elicitation plugin work. I've already put them in there just in case, so I don't need to do that now. So if I want to do this, then the first thing I need to do is to request access to the microphone. Very important. For two reasons. It's for technical reasons, because you won't have automatic access to the media recorder functions of your participant's browser, obviously. So you need to formally request access through some code. And also to inform your participant, which is only polite, that you're about to record them using their device. They need to really know that you're about to do this. And of course, if this is part of your experiment, you'll have added that explicitly in your information and consent page before they even start. Let's pretend we've done that. Your participant knows what's coming. So there's two events happening here. One is the mic request, which is just a really simple plugin called record permission that's prompting the user to permit access to the microphone in the browser. And then the actual record audio plugin itself, which is named audio elicitation, which will again show the by now familiar picture of my cat and prompt a response, in which case this is, how do you pronounce his name? Because my experience has been that there are lots of different ways of pronouncing the name of my cat. So how do you pronounce his name? Please record yourself saying Magnus, or depending on your language, Magnus, 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 or whatever. There's two parameters here that aren't very important. They set the margin of the various control buttons. And I specify here the name that I want the audio file to have. Won't surprise you to learn that it's Magnus. And we push this to the timeline. I'm going to switch off the practice trial for now. We're just going to cycle through our random selection of 4 pets. We should have gotten 100% accuracy now. I'm going to press space, but instead of the experiment ending, we're now going to enable access to the microphone. All right, lots going on here. So you'll see the picture of Magnus. It's a bit small. I might format it. There's the prompt that we specified, and here is a recording light. It'll change its appearance once I click this recording button. So this is how I pronounce his name, Magnus. As you see, we now have access to the recording I've just made. And I have the option of listening back. I won't do it now. I don't think you'll be able to hear it. I'm wearing headphones. And if I don't like it for any reason, then I can either re-record it. But if I do like it, I can upload it to the server. I think I'll do that. And that's the end. All the way at the bottom, this is the data output. So this looks good. I like this. It seems to work entirely as I want. Before I upload it to JATOS, obviously I want to do one quick look whether everything that I've commented is uncommented, because at this point we want the full experiment to work as intended. I'm going to up the sample size to 6, actually, but not to the full 14. So one more quick eyeball, see if everything looks the way that I want it to. Timeline's got everything in it that I want. The final thing to do is here, I want to stop displaying the data on the screen after the experiment finishes. And what I want to start doing is actually uploading the data to where it belongs, our JATOS server, by storing it inside a JSON variable and then uploading it to the survey and ending the study on JATOS formally. There, done. Let's upload it. So this is our real institutional JATOS server, and I'm going to import the study I've just made together with all of its associated materials. I'm immediately running into one problem, which is that I've forgotten to zip, to export the study. I'll do that first. Magnus.jsPsych. Yes, let's save the file. There. It's a small study, so that didn't take long. Now I can import it. Here it is. I've done this before, so there is already a study with the directing Magnus on the server. I have the option to overwrite it. So I'm going to do that. I'm not actually sure at this point whether this has been successful. So to be absolutely sure, I'm going to delete this one. Yeah. This is the study that I've just created. This is the correct one. Let's see if it works. So this is familiar. This looks good so far. The instructions. The practice trial are my main trials. There's 6 of them. My feedback trial. And now let's record some sound. Magnus. Either my plugin is broken, or there's a problem because I'm streaming sound as well as doing this at the same time. We'll check later.
Yeah, because like it has recorded something, right?
Yeah. And if I upload it now, there, that ends the study. We'll be able to see the file in the results. So just click on that now. There's only one result. I've just done it. It didn't take a long time to do the study, about 1.5 minutes. But we'll see an OGG file, which is a sound file, here in the uploaded file. So there's 2 files for this result now. There's the actual result file, which you can export or view. But there's also this external file associated with this result. And you can choose to export those separately if you want. And you can preview the data that we've collected here. Just sometimes useful when an experiment is running. If I want to look into the data and check whether everything's going well. So there's one final thing that I want to show you before I end this. And it's, I want to send you guys a link so you can do this experiment yourself if you want. So just going to go back to the main page. If I want to distribute links to the study, what do? I go to Worker and Batch Manager. There's one batch. You could have several if for some reason you wanted to run this experiment with different groups, for example. But for now, there's only one batch. It's named default. this batch has a couple of properties. It has only 3 allowed worker types. The admin, that's me, a personal single type link or a personal multiple link. So a link that only works for one IP address, either only one time or multiple times. But what I want is a general multiple link. I want to be able to send the link that's the same for everyone, that anyone can use, and anyone can use multiple times. So I'm going to get a link like that in the only batch I have, default. And here we go. I have a link. I'm going to copy it. And I would like to be able, maybe I need to stop sharing in order to be able to share this link in the chat. What do you think, Martin? I really don't do this enough.
I actually thought the same, but I think you can post it in the chat, but we're not included in the recording because when we upload it to YouTube, we won't be able to do that anyway.
No, that's fair.
Yeah.
But you have just seen the link on the screen when I generated it just now. So I guess if you pay close attention to this YouTube recording, you can get the link. But I've posted it in the chat.
And I can confirm that it works.
There we go. So if you're in this Zoom room right now and you want to try this out, then try navigating to that link and see what you get. Right, so we have 2 results already. That'll be you, Martin.
No, not yet. Oh. That was me.
Somebody has already clicked on this link. JATOS has automatically generated a worker ID for them. There's a result ID, like a unique result ID associated with this result. All metadata that can be very useful if you want to keep proper track and documentation of your results. This becomes quite important once you run the kinds of studies that you can run with this sort of interface, which have hundreds, if not thousands, of participants. So that really covers all that I wanted to demonstrate today. This might be a good moment to round off the talk or to take questions from the audience. What do you think, Martin?